Hey there YouTube, SuperBrain AK here, and welcome to USB Device Shenanigans. I've got a couple things for you today, and first off is this 65 watt USB dummy load that I finally modified. And you might remember my old 35 watt dummy load, which had the pass-through port and the power meter built into it. Well, unfortunately, the op amp that it uses to control the transistor is shorted, causing the transistor to pull the voltage down like a short. So, this guy's out of here. I haven't fixed it yet. Maybe one day. But I have added the pass-through ports. So I've got the USB-A input port here. That then goes through some wires here to a circuit board out of a laptop. And I just used whatever it had because it had wires already on it and glued it on. So this is a USB-A pass-through, so I can use this quick charge trigger board that I've had for a long time. And then I have also, so the problem with this is that, it has these other two connectors, but none of the data pins were actually wired to anything because, well, it had no use for them. So I don't know if you can see in there, if you see little copper wires going about. I actually soldered those directly to the pins of the connector onto the board. And so the D plus and D minus are in parallel of all four of these connectors. This one, this one, this one, and that one. And then with the USB-C port, the D plus and D minus is connected to there, but for USB power delivery, you also have CC1 and CC2. And so I took those and brought them out here and put it on this power delivery trigger module. And so I've got the main power coming through here, and it's kind of technically backfeeding into this board, but that will give me a power delivery USB-C output. And that is one of these little modules, which I got in the mailbag video. ZY12PDN by YZX Studio. So yeah, it's got a multicolor LED, and you just press the button to change the trigger voltages. So, now that I've got that modified for both quick charge and power delivery, I can test these 100 watt USB-C and USB-A power delivery and quick charge modules, and these are only buck converters. And so I have had a problem with these. I don't know if you saw these two over here yet, but these were just sitting here. I had them soldered to my DC buffer power distributor, and I was using the USB-C to charge my phone up, which is a OnePlus 9. I know that sounds weird. OnePlus is the brand, 9 is the phone model. That's this guy here. And after a while, they kind of go into a dead state. And I'm pretty sure it's the actual chip itself. So, yeah, so those have died. So with this one, I don't know if you saw the giant heatsink that I glued to it. But yeah, so what I did is I put clear coat for putting on your nails, and put it on all the resistors and capacitors all around here, and made sure to trim these solder connections down from the inductor so that way they're not up at all. And you can see the two MOSFETs there and the control chip. And so put the conformal coating, well, the nail polish on those so it doesn't short out, and then I put a piece of copper. I don't know if you can kind of see that tinge there. It's a small piece of copper. And then I, thermal paste and whatnot. And then I put this heatsink on with more thermal paste, and then glued it down with a UV curing epoxy. Use this Bondic pen, which you just squirt it out, and then use the little UV LED to cure it. So yeah. I glued that on. That's actually also how I glued these circuit boards to it. Once I got everything soldered on. Actually, I'm pretty sure I glued it on, then I soldered. Well, except for this one. Yep, I had to take the heatsink off and everything. But yeah, so let's get into testing, see how much power this guy can do. So, I've got everything set up here, and one last modification I would like to mention that I did to this guy is regarding to the fan. So, it turns on and off with this load switch, so it turns on the load and the fan. It doesn't actually break the current, it just turns off the circuitry controlling the MOSFET. And so it turns off the fan at the same time. Now, I did complain that the fan runs all the time on this one, but that's a different use case. I didn't want the fan current to mess with any pass-through data, pass-through current accumulation that you might be recording on this. But, since this doesn't have a meter built in, you just unplug this and plug your device directly into the meter. So, on this, it can run, the fan can run all the time. So, what that would do is it would allow me to cool off the heatsink between high power runs with just turning the load on and off with the power switch. So, you can start your run, your load test, from a cold heatsink. So, how I did that is I followed back the fan circuitry. It works just the same as this one did with its boost converter here. The boost converter is right in there. You can see the inductor. And so the input capacitor is this guy here. And so I followed that trace back down over to here and then over to here, and then that goes through the board to the other side of the switch. So now this side of the switch, that connects to the main positive rail, which you've got a solder point here for I don't know what extra pass-through daisy chaining these modules. I don't know. And the drain of the MOSFET and the positive of the USB-A. So those all connect together on this rail. So what I did is I cut the trace using a razor blade, and then I scratched the solder mask off and soldered a little connection onto there. A little jumper bridge. So let's get this stuff plugged in and test this out. See how much power it can do with the added heatsink. Okay, so let's power this guy up. So I'm using my DPS 3012 set to 24 volts because this is only a buck converter, so if we want to get up to 20 volts output, we need 24 in. So let's power it up. You can see the fan spins on here. I've got the quick charge trigger in here, and then the Ruidang UM25C with Bluetooth, but we won't be using that today. It's got stating that it's in quick charge 2 mode because I'm using the USB-A, and you can see the power delivery board. It's complaining because it doesn't have proper communication, but that's alright, we'll just let it complain. So I'll switch on the load here. $5 volts. There's 1 amp. Two amps. Three amps. And I believe it cuts out at 3.5, or a little over. 3.6, 3.7. Oh, there's voltage dropping out. Alright, 3.5 amps. So, it's getting a little bit warm. Probably the inductor is going to be the hottest part. There you go, 17 watts there. Alright, let's bring the current back down to 1 amp and then switch it to 9 volts. Nine volts, 1 amp. And bring that up. There's 18 watts, 2 amps. There's 3 amps, 27 watts. So let's see, 29 watts going in, 27 watts going out. So that's pretty efficient. I can hear the fan spinning up on here. Three, 4, 5, 6, 7. Yep, 3.7 amps. So we'll bring this current back down to 1 amp. Go up to 12 volts. There we go. 25 watts, 2 amps, 3 amps, 37 watts almost. Three and a half, 42 watts. Yep. 3.7 amps it cuts out. Drop it down to 1 amp. Turn off the load and let the fan cool down the heatsink. And I'll be back and get you some temperature readings. Alrighty, so some temperature readings later. The inductor only got to 44 degrees Celsius and the heatsink was about 40 degrees Celsius. So that's not too bad. So let's bring it up to 20 volts. You can hear the fan go because it's a boost converter. So whatever the voltage is, it's going to be that on the output of the fan. And it will just increase it if it needs to. There we go, that's 20 watts. And so, yeah, 20.88 watts going in, 20 watts out. That's pretty darn efficient. Starting temperature 39 degrees Celsius and 33 maybe. That was inductor and then heatsink. So now we're at 40 watts, 20 volts, 2 amps. And the inductor is at 40 degrees Celsius. The heatsink is at 35, 36 Celsius. The input wattage is 41.7 watts, and the output is 40.2. So I don't believe I'm going to get full 100 watts out. Oop, something cut out. .5 amps, so that's 50 watts. How's this guy doing? 33 degrees Celsius, that's fine. The inductor is at 42 degrees Celsius. The heatsink is at 38. Yep. Huh. So it can only do 50 watts there. And we'll wind the current down. And then turn off the load. Let the heatsink cool down. And let's switch it to USB-C to test the power delivery function of this. Alrighty, so I've got things set up here with USB-C cables. I've got my 65 watt cable from my OnePlus phone. This can actually do 6.5 amps according to its specs. It's 65 watts is 10 volts, 6.5 amps. So shouldn't have to worry about voltage drop. So coming out from there into the in of the UM25C, and then the out of the UM25C is my Anker 100 watt 10 gigabit cable, and then over to the in port of the dummy load. So I'll get this fired up. See, power comes on. So now, I don't think that the UM25C is able to read the CC1 and CC2 pins, so I don't think it's able to understand the power delivery protocol there. But there's the different voltages, and you can see this guy has stopped blinking red and it is now a solid red, so that means it's working and it's happy. So I don't think we're going to bother with testing currents and maximums on the power delivery port, because we already tested that with the quick charge port. We can just step the voltages up. We've got 15 volts now instead of from 12 to 20. Now we've got 20 volts. So let's crank it. See if we can actually get, whoops. Helps if you turn the load on. Let's see if we can actually get our 100 watts that they promised me. Suppose I should turn this guy back to, there we go, 50 watts. Oop, I guess not. Probably because this voltage is dropping. Oop. Turn the load off. Bring the voltage back up. Bring the load back on. Looks like 2.5 amps is all we're going to get out of this guy. Well, we'll let it cook for a little while. See what the temperatures get to. Currently at 35 degrees on the inductor. .33 degrees on the heatsink. We are drawing 52 watts from the 24 volt power supply, and we're getting 50 watts out. So that sounds pretty good to me. Okay, so the heatsink of the dummy load is at 75 degrees Celsius. And this guy, the inductor, is at 48 degrees Celsius. The heatsink is at 43 degrees Celsius. So, that was about 5 minutes maybe. And we will drop the load. Shut it down, let the fan cool it down. So yeah, this guy should run pretty indefinitely at 50 watts, 47 on the inductor, 43 on the heatsink. So that wasn't too bad. I would call this modification a success, and this modification a success. And thank you everybody for watching, and I will see you guys in the next video.